Hello friends, welcome to Bratati Science class. I am Bratati. So let me introduce about myself. I have done my MSc and B.Ed and I have 13 years of teaching experience in science. So why should you choose BSc, that is Bratati Science class? I will tell you that I explain each and every lesson in one shot, in a very short period of time and in a fun way with day-to-day life examples. So it will be easier for you to understand, recap and prepare for your exam. This is kind of revision classes. Okay, so that's why those who have not subscribed, you can subscribe the channel and hit the bell icon to get the all notifications beforehand. So without wasting further time, let's start today's topic, which is work, energy and power, chapter number 10 of class 9 science. Those who are new, request you to go through the playlist where you can see class 7 science, 8 science, 9 science, all the chapters along with the problems and the exercises. Let's begin work, energy. What we call work in our day-to-day life is not considered work in a scientific way. For example, we are watching TV for a long time, we are getting tired, or we are holding stack of books and we are standing in one place, or we are moving along with the stack of books from one place to another at the same distance from the ground. These are actually work is not done according to science. Then what is work according to science? Let me share my slides with you. Okay, so we can see here the mental work and the physical work. So what to be done in science, we have to apply a force on the object and the object must displace from point A to point B. That is from one point to another. So let me share my screen. See, mental work and physical work is very different from scientific terms. So when we are pushing a wall, the wall, okay, we are pushing a wall. Is it moving? Can it move? No. So whatever energy we are using to push the wall, but as the wall is not moving, no work is done in that case. And when we are pushing a book and the book is moving from A to place B on the table, that means it is changing its position and the force is applied, so work has been done. So what I want to say, if this is a wall and we are applying the force to it, but this wall is not moving further, so here work is not done. But on the table, when there is an object A and we are applying force to it to displace it, the same object at point B, here with the force, the displacement D is also there. So in this case, the work is done. Clear? All right. So next is, according to science, then work is force into displacement. The force represents by F and the displacement by D. So we have to remember the formula W equals to F into D, where W is the work done, F is the force applied on the object, and D is the displacement of the object. Now, in case the force is applied in an angle, then, for example, this is the object and on this object we are applying a force like this. This force is applied with an angle. Then we consider two components of this force. So one is the horizontal component. This horizontal component we consider as F cos theta. The theta is the angle between the applied force and the displacement, and it has a vertical component. When the force is applied at an angle to the object, then it has two components. One is horizontal component, another one is vertical component, and the theta is the angle between the force applied and the displacement of the object. Okay, so in this case, we can see that when it is moving, the object is moving, vertical component will be F sine theta and the horizontal component will be F cos theta. Okay, so we know what is theta. The theta is the angle between the force applied and the displacement. Now, according to Newton's law of motion, we have learned in the last chapter, according to the laws of motion, an object wants to be at rest or in uniform motion until an external force is applied to it, right? So with these laws, we can tell that when an object is at rest, the object is at rest, then only the gravitational force is being applied, the one we call it the weight, that is m into g, the mass and the gravitational force acting on that object. So this is acting vertically on it, on the object, because it is pulling it down towards its center. So here, as the object is at rest, the displacement is zero, no displacement. So are we doing any work? When the object, or we are sitting here, I'm sitting here, I'm moving my hand, but I'm not displacing my position. The earth is pulling me down towards the center. Am I doing any work? Though I'm speaking, though I'm teaching, but actually I'm not doing any work according to science. So work done is basically F into D, which is 0, as one component is 0, D is 0. So work done is also 0. So when an object is moving horizontally, then the theta is, that we will consider cos theta. So that means moving horizontally, that is F cos theta. So the displacement is D from point A to point B. So the work done will be this component, that is F cos theta into the displacement, into the D. Now, if the force, this is force, is being applied on this object and the object is at point A, from point A, the object will move to point B, the same object is now at point B. So there is a displacement of D. The force and the displacement is towards the same direction. That means the angle between them is 0. So here the theta is 0 degree. So we know cos 0 degree equals to 1. That means W equals to F into D. That is, maximum work is done when the object is moving towards the direction where the force is being applied, right? So here remember W equals to F into D. If you have theta's value, if you have F or D, you can find out the work done. Then there are different cases. So let us discuss the different case. First case, when theta equals to 0 degree. That means just now we discussed the force and the displacement is the same direction. Both are in the same direction. So the angle between them is 0. So theta equals to 0 degree and cos 0 degree equals to 1. So in that case, W is equals to F into D. The maximum work is done. In case 2, the theta is considered as 90 degree when the object is being pulled gravitationally downwards. Okay, that means, and it is moving towards right side or left side horizontal way. So the angle between these two, the force and displacement, is theta. So as the theta equals to 90 degree and cos 90 degree equals to 0, so no work is done. The W equals to 0 in case of an object is at uniform velocity, that is, it's only being pulled downwards. I gave you the example, you remember? I'm carrying a stack of books, but I'm moving horizontally. Okay, that is, the displacement is there, but the force is being applied downwards, the gravitational pull. There is no work done. Case number 3, where theta equals to 180 degree. What does it mean? This is the object and this object is moving horizontally towards D. Okay, so this is the object and here is the displacement. Okay, but it has a frictional force which is exactly opposite towards the force it's being pulled to, right? So the frictional force is acting towards the opposite side of the direction of movement of the object. So the angle between these two is 180 degree. Now 180 degree is minus 1. Cos 180 degree is minus 1. So the work is being done, but it is negative. That is in the opposite direction. So from this we can infer the work can be positive or negative. When the object is moved towards the direction of the force applied, the work is done positively. But when the displacement of the object is in opposite direction, the force is applied, then it is negative work done. Clear? Now moving to centripetal force. Centripetal force is the force that is applied on an object which is in the circular motion. That is a circular path as in the picture. You can see this is the center of the circle. There is an object. This object is moving like this. Every moment the displacement is there. Okay. So the force acting is constant. An object when in the circular motion, the force acting on the object is always constant and it is towards the center. The force every time is acting towards the center. But in case if the force is not there, the object will move away in a tangent direction from any point of the circular path. So when the object is moving towards the tangent and the force is applying this way, there is an angle of 90 degree. Do you agree? There is an angle of 90 degree each and every position. That means theta is being 90 degree. So we need to take cos 90 which is 0. So that means when an object is moving in a circular path, no work is done scientifically. How are we finding? We are calculating the theta 90 degree, 0 degree or 180 degree. We are taking the horizontal component cos theta and we are getting the value. Clear? Now, what is the funda or formula of work done by spring? This is the normal condition of the spring. The spring length is L. The spring length is L. Now, first case is expansion. We are expanding the spring. So, this was the L. This was the L length. And from here, when we are pulling the string, we are expanding it. It is displaced D distance. But when we are expanding according to laws of motion, the object wants to remain at its own position. Own position is the spring force will act towards the opposite direction. This is force spring which is acting upwards to the external force applied on the spring. So the theta here is considered as 180 degree. And if theta is 180 degree, the value of cos 180 degree is minus 1. So as the spring force is the opposite towards the external force, the work is done but in negative. Similarly, we consider when the spring, we are contracting the spring. When we are contracting the spring, this was the initial position L. From there, displacement D. When we are just pushing it back, we are pushing the spring back. But the natural, the tendency of the spring is to be its original position. It wants to be back at its original position. That means the F spring, the force of the spring is acting just opposite towards the external force. And the angle here is similarly 180 degree, right? So this side is the external force, this side is the spring force. The angle between them is considered as 180 degree and this 180 degree equals to minus. So the work is done here also but in the opposite direction. What about the object that move upwards? So as you know, this is the object at point A. The gravitational pull is acting downwards, which is mg. And similarly, when we are pulling it up means we are applying a force upwards. So the object is now at the position B. at the height of H and the force applied is F. So again opposite direction. So the theta will be considered as 180 degree. Cos 180 degree is minus. So work is done because we know F equals to mg and h. M is the mass, g is the gravitational pull, and h is the height that the object is moved. So W will be minus mgh. Now, what is the unit of work we are talking about? W equals to F into D is the formula. Force, the SI unit is Newton and CGS unit is dyne. And D is the distance or displacement that is considered in SI meter and CGS centimeter. So, the work unit will be Newton into meter, or we call it Joule, Joule in SI, and dyne into centimeter, we call it arc in CGS. So we know SI unit of work done is joule, CGS unit of work done is erg. Now coming to page number 115, exercise 10.1. See, if you have the NCERT book, we are doing from this book, NCERT book of class 9 science. 10.1. Here it's given a force of 5 Newton is acting on an object. So they said the force applied is 5 Newton. Acting on the object is displaced through 2 meter in the direction of the force. So it is the positive work. The displacement D equals to 2 meter. So work done, we know this is F into D. F into D. Here F is given 5 Newton, D is 2 meter, 5 to the 10 Newton meter, or we can say 10 Joule. Done. Now moving to the next one, that is exercise 10.2. Here it is given a porter lifts a luggage of 15 kg. So M equals to 15 kg from the ground and puts it on his head. That is 1.5 meter displacement of the object. H or D. Calculate the work done by him on the luggage. So W equals to mgh, F into D. Here D is H. Okay. D is H here. And F equals to, we can write M into G, that is mass into gravity. Gravity is 10 meter per second. That is the universal constant G. So it is going to be 15 into 10 into 1.5, that is 225 joule. Children, you will be getting calculator for calculating during the exam. So you just have to calculate, and in easier way, if you remove one decimal, then 10 will go. So that is 1.5 into 10 equals to 15. So 15 into 15, 15 whole square, that is 225 joule. Now we are moving to energy. What is energy? The energy is capacity of doing work. So with this, we can understand that energy and work are interrelated. That is, work and energy, they are related to each other. Now, there are different forms of energy. The different forms of energy can be potential energy, kinetic energy, heat energy, light energy, solar energy, nuclear energy, sound, chemical, geothermal, etc. So potential energy is the amount of energy or the energy that is there in a body when it is at rest. When it starts moving, there is a velocity, and then it changes to kinetic energy. Clear? Heat energy when coal are burned or any other like paper burns, from their heat energy evolves. The light energy we get from sun, we get from any other light sources, whether it's lamp or any tubes and so on. Solar energy we get from sunlight, which we use for solar panel, solar cooker, solar car, etc. Nuclear energy, which can be of two types, that is fusion and fission. When two nucleus joins together to form a bigger nucleus, we call it fusion. When two nucleus are joined together to make it a bigger one, we call it fusion. And when from a bigger one, it breaks down using the energy, and with that two different nucleus is formed plus energy. So when this when this phenomena happens, that they release the energy and they gains the energy to produce a new one. So fission and fission of the nuclear energy, this energy has been taken for creating the nuclear bomb, atom bomb, etc. There are sound energy that we get from crackers, we get from loudspeaker, mic, etc. That is also energy. Chemical energy, when two components mix together and they form a reaction. The two components, we call them reactants, and that is called chemical energy. The geothermal energy, that is also used to produce the turbine. We get the wind energy, the water energy, the wind energy. So geothermal, which is present ground the earth down, okay, inside the soil, we call them geothermal energy, etc. Now, the mechanical energy is the combination of both kinetic energy and the potential energy. Because the as you know, the kinetic energy that is possessed by a body when in motion, the object is in motion, we call them, it has might be a velocity. It can be uniform velocity or it can be changing from u to v, initial to final velocity. So kinetic energy is half plus mv square, half of mass into velocity square. So where m is the mass and v is the velocity. The unit of kinetic energy is joules, Newton meter. Okay. Then work energy theorem. What is work and energy theorem? As we know, energy is the ability to do work. So energy and work are related. So what is their theorem? Their theorem is when any work is done on an object, that work is equal to the change in Ke or kinetic energy of the particular object. As I told you, it has a must have a velocity. That's why it's moving from one place to another. So this work done is equal to the change in the kinetic energy of the object. So W equals to delta Ke. Delta is the change in the kinetic energy. Initially, the object has the velocity u, and then after certain time it has v velocity. So what is the work done on that object? As it's in motion, we can consider only the kinetic energy, which is half m, which is common. Within bracket, it will be v square minus e square. So basically, it is half mv square minus half mu square. And from there, we have taken this half mv as a common and the rest in the bracket. Got it? So this is how we can find out when a body in motion, then what will be the work done on that object. Now coming to the potential energy. The potential energy is considered when the body is at rest. That means no velocity, zero velocity. So if the velocity is zero, we consider only the weight, that is the gravitational pull. The energy possessed by a body by virtue of its position, shape and configuration, whether it's circular or it's a square or it's heavy or less, so what is the mass is more or less. So here we consider W equals to mg, that is the weight, into the displacement height. It is at the height of suppose 7 meter from the ground. So here we consider W equals to mgh is the potential energy of that object. Now coming to the laws of conservation of energy, you know that this is energy can neither be created nor destroyed, only it can transfer from one form to another. Just now we discussed the different forms of energy. The sound energy can be converted to any other energy. The wind energy in the windmill can be converted to electrical energy. Okay, the water from the dams that are being collected to generate the electricity, so their water energy is being transferred to electric energy. The sunlight, the solar light can be used to make solar cooker to cook the food, so the sunlight or the solar energy can be converted to chemical energy. So like this, the human energy can be converted to the potential energy. For example, consider the bow and the arrow. So what do we do? The bow, we hold it. Now at the rest, what is that? It's zero. Human energy, the potential energy. When we are pulling the string, and the bow will release, the bow starts moving towards front. They get the velocity. That is the kinetic energy. So potential energy transfer to the kinetic energy. Now let's see how this convert from potential energy to kinetic energy. So when the body, so there is a body which is at the rest. This is the ground. Here is the body. The body is at point A. And when at the rest, it has potential energy which is, it's not moving, it's at rest. So it is mgh. H is 0. H is 0, then potential energy is 0. Now we are throwing it up, the pulling it up, whatever you say. And the object is at now point B. The distance is h and the force is applied F. Okay. Now here on that point B, when the object is moved towards the upward, for a certain time it will be 0. I mean it will be a constant, and after some time it will again start dropping down because of the gravitational pull. So at that point of B, that mgh is maximum because it is at the height h, right? Whatever is the height h. But B is 0 because it is constant and at rest at the top. Then V is 0, no kinetic energy. So potential energy maximum at point B, is it clear? And kinetic energy is 0. But when we drop the objects, or with the dropped it from there, it's coming down. Then when it's coming down, it gains the velocity. And that velocity can be the maximum one. So when it's down, then the kinetic energy is maximum. That is half mv square, where the potential energy is 0 because h is 0. So that means at point B, potential energy is mgh, but kinetic energy is 0. So total energy is mgh. But at point A, the object dropped. Their potential energy is 0. And kinetic energy is half mv square. So total PE plus KE equals to half mv square, where V is the maximum. So from this two equation, as we know that energy just convert or it's conserved, it cannot be conserved, it cannot be created or destroyed, just it transfer. So mgh equals to mv square. Okay, if we solve, we can get V square equals to 2gh. Pendulum, what happens during the pendulum? Remove this also, it will not go away. In case of pendulum, this is the pendulum, this is point A and this is the point when it is at the height 8, or not this, but when the pendulum is moving, it's going to the height h from the rest, and then again it's coming back, moving to the point. Suppose this is point B and this is point C and this is point D. So from D to B, B to D, D to C, C to D, it's like that pendulum movement. So again same way, when it's down to a certain point B, the potential energy will be maximum because it attains the height h, where there is no velocity. For a certain time it will be stopped. Again it will come down with the velocity V max, that is half mv square. So mgh equals to half mv square. You can consider this is for the same objects where m equals to small m. Now page number 118, 10.3. I hope this much is clear. 10.3, it said an object of mass 15 kg. So the m is given as 15 kg. This is m, is moving with an uniform velocity of 4 meter per second. So v is given 4 meter per second. We have to find out the kinetic energy, where this is half mv square. So half we know 15 kg and v square. So this is 120 joule. So kg meter per second, that is the Newton meter, or 120 joule. And 10.4, it says in 10.4, what is the work to be done to increase the velocity from u equals to 30 kilometer per hour, as it is in kilometer, we have to convert it to meter per second. So 30 kilometer into 1000 divided by 3600, then we can convert it to meter per second. Similarly, the V is 60 kilometer per hour. That also we convert to this meter per second. The work to be done. You know this formula, the work energy theorem. The work to be done is kinetic energy V minus kinetic energy U, which is the solve, and we get this. Right? Now 10.5. 10.5. Find the energy possessed by object of mass 10 kg. M is given as 10 kg and is at height of 6 meters. So H is 6 meter. G is constant. We for easy solve, we can, if it is not given, we take is 10 meter per second. If it is given, 9.8 meter per second square. G equals to 9.8 or 10 meter per second square. So potential energy is mgh, that is 10 kg into G, that is 10 meter per second square, and 6 is meter. So 600 joule, Newton meter per second square. And 10.6, an object of mass 12 kg. Mostly you will be knowing the mass of the object. The G consider 10 meter per second square. So if the potential energy is given, here EP is given, that is 480 joule is given. Find the height, we don't know the height. So M into G into H here. M is 12, G is 10, H is, we don't know, equals to 480. From here we can find out what is H, that is 4 meter height. So the object is at height of 4 meter. Now moving to the power. The power is the rate of doing work, that is work upon time. We can consider as P equals to W by T. When you know any two of this, either you know PW, you can find T, you know WT, you can find P, and so on. The unit of power is watt, and it's a scalar unit. You know, scalar and vector. Scalar units are those which have only magnitude, no direction. But vector units are those which have both the magnitude and the direction. So what is the power? 1 watt is 1 joule per second, because work done is joule in SI, then T is second. So 1 joule per second is equals to 1 watt. That is the unit of power. Commercial unit of power, the question comes is horsepower or HP. Because sometimes you may get the question in horsepower, you have to convert it to watt. 1 horsepower equals to 746 watt. These things to be keep it in mind forever. 1 kilowatt is 1000 watt. We are just converting it into by multiplying with 1000. Done. So horsepower 746 watt. Now 10.7 exercise 10.7 is saying two girls are there, consider A and B. Each weighs 400 Newton. So their mgh is given, that is 400 Newton. So their height is 8 meter for both of them. The only thing is girl A takes 20 seconds to climb up and B takes 50 seconds to climb up. What is the power expended by them? So here girl A power mgh by time, and girl B power also same. So mgh is 400 for same, into h is 8 for same, but T differs 20 and 50. Consider and then you get this, right? Next, coming to 10.8. This is 10.8 sum. In 10.8 it said a boy of mass 50 kg. So we know mass is 50 kg. Where is that? M equals to 50 kg. Runs up staircase of 45 steps in 9 seconds. So T here equals to 9 seconds. And each step is 15 centimeter, then 45 steps equals to 6.5 meter, which is divided by 100 because it is in centimeter. Centimeter to meter, we have to divide it by 100. We got in meter. So power is given G equals to 10 meter. G is given 10 meter per second square. So power is mgh by T. So we know M is 50 kg. 50 kg. G is 10 meter per second square and H is 6.7 meter divided by 9 second. So answer is 375 watt. Now we are done. Coming to the exercise. Now see in the exercise what we have. Suma is swimming in the pond. Understand whether work is done or not. So Suma is swimming. It's moving forward and the force is being acting downwards. So the angle is 90 degree, moving horizontally, cos 90 0. No work is done. Similarly, donkey carrying load on its back. So donkey carrying load on its back, fine. Mg is working, that is Mg is working, and moving forward, no work is done. Windmill is lifting water from a well. There is a height, increase in height. Windmill is lifting the water from a well, increase in height. So MgH will be there. So the work is being done. Okay, the displacement is there, and cos 180 degree will be -1. So work is done but negative, right? Green plant is carrying out photosynthesis. Is it the work done? Chemical reaction is going on. So that means no. Work is done because water is being taken and then with the help of sunlight they are producing no. An engine is pulling a train. Similarly, no work is done. So number 1, we are just moving to exercise. In that, number 1, all this no work is done. No work is done. An object is thrown at a certain angle to ground, moves in a curved path and falls back to the ground. So first it moves up and in a certain angle, remember there is a theta, to the ground, moves in a curved path. It's saying an object is been started from point A and came back to point B. A to B. See, same horizontal line. So there is no H. H is 0. If H is 0, then MGH is 0. So no work is done. Third, a battery lights a bulb. Describe the energy changes involved in the process. A battery is the chemical energy. So in the battery we have chemical energy and then the bulb glows out of it. So this is chemical to light energy. Certain force acting on 20 kg mass change its velocity from 5 to 2 meter per second. Calculate the work done. So mass is given 20 kg. U is 5 meter per second and V is 2 meter per second. So we know, calculate the work done. W equals to half m V square minus U square. So half into 20, V square is 4. Negative work done, minus 25. So 10 into minus 21. So this is minus 210 joule. Fifth one, a mass of 10 kg is at the point A on table. It's moved to a point B. If the line joining AB is horizontal, what is the work done? By the gravitational force. Now, fifth one, they are saying mass is there. Mass is 10 kg. But if this is the table, it is in the point A and here is the point B. This is, here mg is acting. Here mg is acting. It's moving to a distance d. But is any work is done? Work is not done because, why? It is 90 degree. 90 degree means cos 90 equals to 0. Here theta is 90 degree. So W equals to mgh, that is, you can write F into D. Here F cos 90 is 0. So no work is done. This is fifth. Sixth one, potential energy of freely falling object decrease progressively. Does this violate the law of conservation? Why? Potential energy of a freely falling object obviously we'll discuss because H is being decreased. But then it's getting the velocity. So when it's getting the velocity, the potential energy is changing to the kinetic energy. So it doesn't violate the laws of energy. Potential energy decrease, but kinetic energy increase. Hence, laws of conservation of energy is followed and justified. Number 7, what are the various energy transformations that occur when you are riding a bicycle? So when we are riding a bicycle, we are moving forward, mechanical energy, some heat is being generated, frictional force is there, right? Does the transfer of energy take place when you push a huge rock with your all might and fail to move it? Where is the energy you spend going? So it is, what happens here, no work is done because a huge rock, there is no displacement. If no displacement, then there is no work done. Okay, the energy, the mechanical energy is getting converted to heat energy. The heat is being generated. So here, as the huge rock didn't move, work is not done. Does the transfer of energy take place? Acha, done. Number 8. This is number 8. So there, I hope you liked today's sessions and enjoyed, learn something new. So if you like any part of the video and you have learned something today, please hit the like button and share with your friends so that it reaches, BSc reaches to every corner of the world. So we are rocking together. Very soon I'm planning to have a live session for you guys. So stay tuned, stay happy, keep learning. See you in the next class. The rest of the question answers will be done once I get a comment that you really need it so that I can share the notes for you. All right, take care. Bye bye.